we're trying to figure out the domain of f of x is equal to 3 by 4x minus 4 minus x square, so on and so forth. So there are two conditions. We cannot have 2 and minus 2. I hope you guys can understand. From the first expression, this is the condition. From the second expression, we know that it has to be more than 0. This particular expression has to be more than 0. So everything else is okay. So let's see. Can we eliminate anything? No, we can't eliminate anything per se. It looks like B and D we can eliminate, but again, there is a cube, and x cube minus x, it can lead to weird things. Now, so there's nothing that we can do over here. Let's move on to the next step. So it has to do with x cube minus x, because 2 is nowhere, right? Not included anywhere. So we can ignore the first expression. We just have to look at this expression. So let's factorize this. So we have x square minus 1. So x into x plus 1 into x minus 1. So all of this has to be greater than 0, right? So where all can we have? Well, we can pretty much have everywhere. So option cannot be this. This is too small of a range. I mean, the space. It can be, it can go to positive values. All the positive values are there. So this is also eliminated. That is 2 to infinity is there. So it has to be option C, if not D, right? So the question is, in option C and D, we have this set of values already. So we're looking at minus 1 to 0. Is it a possibility? Is it okay for me to substitute minus 1 over here? Not including minus 1, that is. So minus 1 will be minus 1 plus 1. This will lead to 0. So if I substitute some minus 0.5, so that will be, yeah, it can. These are fractions. So x cube minus x will be greater than 0 for fractions, because minus 1 to 0, there are fractions, right? And this expression leads to it being positive value. So answer has to be D. Okay. Now let me explain in detail. So in exam, that's how you have to do it. So let's look at things in detail. Let's look at the first expression. 3 minus 4, 3 by 4 minus x squared. Since we're looking at domain, that is the set of values which we can use as an input value. So we need to consider here 4 minus x squared. We cannot have values which is equal to 0. So when will they be equal to 0? When x is either 2 or minus 2. When you simplify this, right? This would be your answer. Is it not? This is a set of values wherein this expression, the denominator, becomes 0. So we cannot have that. X cannot be equal to 2 and minus 2. So that's one of the expressions. Now the second expression. Second expression has to do with log 10 with some expression. This has to be greater than 0. Sorry, log deals with values which are greater than 0, right? So the expressions has to be greater than 0. So what is the expression? X cube minus x has to be greater than 0. Now, when we simplify, we saw that we end up with this particular expression. Now, when I take up the number line, we know that it becomes 0 at 0. The 0 lies over here, and the graph will go here and go here. Okay, I hope all the fundamentals are strong. So any value before 1, it would be, sorry, I wrote it ulta, my bad. This is supposed to be positive and this is supposed to be negative. So any value before this, what will happen? Minus 2, this will lead to a negative value, into this will lead to a negative value again, and this is also a negative value. So this is a no, right? And the graph here, it will be positive. It has to be so, right? Let's see. So any value like 0.5 negative, this also will be negative. This will be positive and this will be negative. So negative, positive, negative. So this will be positive. So this is an okay. And between 0 and 1, we have all of this 0 and fraction, positive, positive, and this is negative. So this is a negative and this will be positive. So is that right? Minus 1 to 0, 1 to 2. Yeah, 2 cannot be part of the values that we know why. And so we can see that yes, answer D is the right option. Again, try to make use of the shortcuts, right, before going to direct mode. Okay, MCQs works best if we try to use the properties and understand the concept and apply it and jump to the answer.